Good afternoon, and welcome to Blueprint for Clean Energy, a webinar speaker series hosted by the Yale Center for Business and the Environment. My name is Neil Kincannon, and I will be your host for today's webinar titled Opportunities and Obstacles, a conversation with the National Renewable Energy Lab on microgrid deployment in Sub-Saharan Africa. The Blueprint for Clean Energy webinar series invites leading practitioners and researchers in the field of clean energy to talk about the latest opportunities and developments in corporate, nonprofit, and public-private arenas. In this webinar, we will discuss the work the Renewable Energy Laboratory, or NREL, is doing with local developers and governments to accelerate microgrid deployment in currently, or up until recently, off-grid communities in sub-Saharan Africa. We look forward to learning more about their work, the tools that have been created to facilitate smart policies for pragmatic energy access expansion, and where they have seen opportunities and challenges to effective microgrid deployment. Joining us today from Golden, Colorado to talk about all these things is Eric Lockhart, who is a project leader at NREL. Among other things, Eric leads research on sustainable business models and financing for microgrid expansion in sub-Saharan Africa to provide energy access, pathways for microgrid cost reduction, and optimal deployment of batteries in microgrids. I'm obliged to plug that Eric is a graduate of Yale College and also earned graduate degrees from Yale's Jackson Institute and its School of Management. So Eric, it is our pleasure to have you on the webinar with us today. Before we begin, I have one quick announcement. The Yale Center for Business and the Environment is proud to announce the launch of its new certificate program, Financing and Deploying Clean Energy. This year-long admissions-based online certificate program equips rising leaders with the tools they need to accelerate the transition to a clean economy. Learn more at cbey.yale.edu/certificate. And a quick reminder to our listeners, and then we'll get going. We welcome any questions that you have throughout the presentation, and we'll direct them to our speaker towards the end of the talk. If you do have a question, please type it directly into the Q&A window throughout the presentation. And with that, I would like to turn the floor over to Eric.
Great, thanks, Neil. Go ahead and share my screen here. How's it look?
Looks good.
All right, great. So yeah, thanks for that introduction, Neil, and thanks for including me in this webinar series. I'll start with Neil sort of introduce the projects I'm working on here. So I'll start with a little bit of introduction, then talk about the agenda for what I'd like to cover, and then dig into microgrid deployment. So by way of introduction, Neil mentioned a little bit about my background at Yale and elsewhere, but my background is actually in finance and international development, and then I moved into the clean energy space here at NREL. So that's sort of the perspective I bring to the microgrid deployment space, but I work with a bunch of electrical engineers whose perspectives I'll try my best to represent here as well. And I'll mention, I know that other aspects of this series are a little bit more domestically oriented, so I'll mention just one other project that I've been working on at NREL here. It's called the Solar Energy Innovation Network, and it might be of interest to some folks on the line here. It looks at, in the U.S. context, questions like locational value of solar, if solar and storage can provide resiliency benefits to the grid, economics of DER aggregation, and sort of a host of other solar DER things that might be relevant for folks here. All right, with that brief introduction out of the way, this is the agenda of what I was hoping to cover here. I have it broken up loosely into two general parts. Understanding that this series is more often domestic than international, I wanted to make sure to include some background about why we're looking at microgrid deployment, what the nature of the electricity access challenges and so forth. I'll highlight some of the barriers and then get into some of the work that we've been doing at NREL and some of our partners and other sort of sister organizations have been working on to try to support microgrids in achieving scale to reach electrification goals and energy access goals. And I'll note, I'm going to talk about a broad suite of different projects and efforts at NREL and elsewhere, of which I only work on a slice of them. So again, I'll try my best to represent them here, and I'm looking forward to Q&A at the end. Very briefly, NREL, for those who aren't familiar, this is our campus in Golden, Colorado. It doesn't look like that today, actually. We have some East Coast fog here today, and it's going to snow allegedly tomorrow and the next day, and then we'll be back to this sunny picture by the weekend. So we have, as you can see, a ton of solar deployed here. NREL has been researching renewable energy for for decades now, and has been increasingly working in sort of a more applied space in addition to basic research that we've been doing for a long time. And over the last 10 years or so, we've been doing more and more international work as well. And this is just a small part of NREL's broader international efforts. So the work that I'm going to talk about today in particular comes largely from a project here at NREL over the past couple of years that's supported by USAID's Power Africa program. Power Africa is a very large program that's targeting increased connections and increased capacity in power systems in Sub-Saharan Africa. And within the broader program, which includes things like transaction support for closing kind of more bulk power level deals, Power Africa also has this Beyond the Grid program, of which NREL's work is just a small slice. And for us, we're focused on implementing something called the Quality Assurance Framework, which I'll talk a bit more about in a little bit. So for the Power Africa project at NREL, we sort of have these three primary pillars of support. The first is technical assistance to developers. So we work with developers in Sub-Saharan Africa that are grappling with technical challenges of rolling out microgrid programs. And as we'll discuss more over the course of this webinar, broadly speaking, the Sub-Saharan African microgrid industry is in kind of a still sort of earlier emergent stage where there's a lot of experimentation and piloting and demonstration. So our work with developers has been sort of grappling with some of their technical challenges on how they grow their businesses, to include working with them on how best to select and operate batteries in their microgrids, how to construct customer agreements that clearly communicate the power services that will be supplied to communities, and things like that. So growing out of that work with developers, we've been getting a lay of the land of some of the principal challenges that developers are facing when deploying microgrids in Sub-Saharan Africa. So we've identified areas where we can put together reports that sort of support the industry at large, and sort of moving to the next stage of scale. So the second half of this webinar of my presentation will focus more on those discrete topics that we've looked at closely to try to help do our part to help move the industry forward. And then finally, a very important piece of the project is working with government entities to support development of the enabling environment. We've been working with a number of different Sub-Saharan African countries that are working on sort of a variety of different microgrid related challenges, and we try to share our perspective on technical aspects of things like standards that they're trying to put together, as well as sharing our perspective from our work with developers to date. And that work with the national government, obviously supported by those reports that we put together to serve the industry. Okay, so taking a small step back, I just wanted to talk about the scope of the challenge here and why microgrids would be a compelling thing to talk about with respect to this energy access challenge. So the NREL project and Power Africa are more focused on Sub-Saharan Africa. Power Africa is in the name, but most of what I'm going to say also translates to other locations where there's still where electricity access issues remain. And the approaches to electricity access are also largely held in common with places that have already achieved electricity access. So by and large, this is kind of using similar tools to apply to a new problem. So the bar chart on the top there is tracking the off-grid population in Africa over a couple of decades there. And what it's showing is there has been a lot of progress in expanding electricity access in terms of number of connections, but that so far has not kept pace with population growth in a subcontinent that's still largely rural versus urban. And if you look at the countries involved, you can see in that left-hand chart that there's a number of economies in there that are rapidly growing but still have large off-grid populations to reach yet. This also makes a note of on-grid with unreliable access, which I'll touch on a little bit later as well. That there's sort of a large population to address. Even in Nigeria, an economy that's growing rapidly, still a pressing challenge to meet electricity access goals. So when I mention electricity access goals, there's obviously international goals codified in things like the Sustainable Development Goals, and also with all the countries we've been working with, they all have, by and large, ambitious electrification goals to get to 100% electrification as soon as they can. So our work tries to respond to their goals to reach their targets and the timeframes they're looking at. So there are three primary ways to extend the electricity access out to folks who don't have it. I listed them at the bottom there. The traditional approach is grid extension. That'll be more familiar to folks on the one side of the spectrum. On the other side, we have solar home systems, which will also probably be more familiar. And when I use that term here, I'm thinking about kind of an individual household that has a small solar panel and a small battery. In the African context, for maybe a couple of light bulbs or a cell phone charger. And microgrids sit in the middle there in a number of ways, but they're set up to serve a community of say 100 or 200 or 300 households, and can provide solar home system level electricity service, but can also be invested in and configured to provide grid level electricity service. So out of these, in Sub-Saharan Africa, 600 million people, which is roughly 2/3 of the population who lack electricity access. Some are in good places to get grid extension, although there are some challenges with the main grid in some large cities and some of the countries that I've listed there on the left. But some will certainly be served by grid extension, many. Some will be too remote to be a good option for grid extension or microgrids, and there'll be solar home systems. And some hundreds of millions in the middle are estimated to be most cost effectively served by microgrid deployment. There's some good IRENA reporting on that, just to look at the proximity of people to power and where it makes most sense. I'll talk about the economics of that a little bit more in a few. So just at a high level, what do we mean by microgrid? This is a photo of a PowerGen renewable energy central plant here. This is sort of a fairly common configuration. This one might be a little bit smaller than some of the other ones I'll be talking about, but the idea is some combination of solar storage and sometimes diesel generators that provide electricity service to, again, maybe 100 or 200 or 400 households in the community, and power cell phone chargers, lights, TVs, radios, refrigerators, maybe ice makers, maybe sewing machines. And I'll talk about those devices a little bit more and what we might hope to see there. Those are the fundamental attributes. Most microgrids that exist in the world today are diesel-based microgrids, but a lot of the work we've been doing through this program is focused on solar and storage. Obviously, that's more NREL's expertise, but it's also commonly what developers are already doing and what national governments are interested in. PowerGen does a hybrid typically of renewable energy storage and diesel generation. All right, so I think to talk about the microgrid business model and some of the barriers, it's helpful to start by thinking about a more traditional utility model, and let's say the United States as an example. So this visual just shows the sort of a simplified version of the key players and how this works to make a utility investment in the United States an extremely safe long-term investment. So the consumers are reliably supplying revenue to the power supplier, who's reliably supplying electricity to those consumers. And because of the reliable revenue stream and economies of scale, costs remain low, so there are returns to supply back to investors in return for their investment and infrastructure and generation and everything that goes into operating the power system. If we look at a mini grid in Sub-Saharan Africa, a number of aspects of what makes the utility model easy and low risk break down a little bit. The economies of scale are lost, obviously, when you go from are lost to some degree when you go from a large main grid that has a number of sources of demand and supply and has existing infrastructure. When you go from that world to supplying power to an individual community, there's still opportunities for scale, and I'll talk about that later. But you start from kind of a higher minimum cost perspective for power provision to remote customers. So on the cost side is going to increase. On the revenue side, generally speaking, it's providing electricity to folks who haven't had reliable electricity access before. So there's a challenge in understanding what cash flows will look like over time and managing the revenues to recover capital costs and operating costs for microgrids. So those challenges between the power supplier and the consumers sort of either trickle down to the investor, where there's challenges in recouping the investment on a time frame that makes sense, and it's fundamentally just a riskier investment that's not quite as well understood from an investment perspective. So those challenges are well known and sort of have been out there for some time. So we put together this little menu of different options for what business models are starting to look like and what they might look like in the future for microgrid businesses. So these will look by and large similar to the menu of options for a utility, again, let's say in the United States. But the aspects of this menu that are being currently used in the microgrid deployment context in Sub-Saharan Africa are slightly different, and there'll be a transition, I think, that we'd all like to encourage to drive scale here. So I'll review this in brief, that the mechanism of project initiation, again, will look similar, at least for those first two, tender RFP, or a developer-driven model where the developers identify sites and pursue projects that they feel are economically viable. And the donor-driven category is where most projects are currently initiated for microgrids in Sub-Saharan Africa, and it's an option that's not often used in the United States and is more used for kind of new applications of technologies rather than sort of bread and butter power provision. On the mechanism of financial backing, this is also a place where each of these kind of tools or aspects of this menu of options are deployed in the traditional utility model. The microgrid model also has aspects of these, but again is more skewed towards subsidies and concessionary loans, funding of that nature, and would really like to move into the private investment zone to be able to unlock additional investment to reach some percentage of those 600 million people. I'll skip over to the mechanisms of ownership quickly. Again, that's similar, and in all likelihood, in the microgrid context, will involve some combination of those, as it does in the United States if we look at the different utility models between IOUs, co-ops, and munis. And then on cost recovery, this is something that's a little bit different from in the microgrid context and will probably remain so from the utility context in the United States. With microgrids, it's often prepaid cost recovery with preloaded power usage drawing on kind of dramatic mobile money availability expansion over the last 5 or 10 years. So I want to talk about costs of microgrids a little bit before talking about barriers, and then turning to some of the things that we've been working on at NREL to try to help advance this market a bit. So these costs are from a recent report on tariff considerations that I'll talk more about in a moment. You can see just by looking at the left hand, the vertical axis there, the y-axis, that these costs are very high compared to grid costs in Sub-Saharan Africa or in the United States or elsewhere. We looked at sort of 3 different technology combinations. There's a PV plus battery version, there's a diesel only version, and a PV plus battery diesel version. And we used our optimization tool to come up with the ideal way of sizing and dispatching those systems to pursue a least cost option in each of these locations to serve a 100 household community. And you can see in Ghana, for example, the PV plus battery solution is coming in around $1 per kilowatt hour, which might be anywhere from 5 to 10 times the prices in Accra, Ghana. I'm not sure what main utility prices are, but certainly that dollar will be several times what people are paying in the city. You can see, as with the diesel system, the LCOE is a bit lower, and then with the combo where you can use all 3 options, it's lower still. The difference between Ghana and Zambia on the PV plus battery is the difference. It just is driven largely from the solar radiance profile in those 2 places. Ghana's solar is not fantastic, but it is consistent. So in the case of a microgrid, that's really important for system sizing and economics. It's certainly not it's not something that can't be overcome in Zambia, but Zambia is much more seasonal, and systems have to be a little bit more overbuilt. So sometimes they're the right size, sometimes they're not exactly the right size. I wanted to provide one more perspective on costs, and then I'll talk about some of the barriers I've already touched on before talking about some solutions. So the Rocky Mountain Institute is also doing a great deal of work in this space, as are a number of other organizations. And they recently looked at what it might take to decrease costs for a well-run larger system. So this visually here is their take from last year on the LCOE of a slightly larger system. And you can see there, this would be 700 connections. The systems that we've been focused on at NREL are more in the 100 or 200 connection zone. You can see it's around 60 cents per kilowatt hour for a best case scenario for a larger system that can take better advantage of economies of scale, which is still likely too expensive to be sustainable in the long term. But this chart is also useful to just look at the different pieces of the cost profile. And we'll see some of the work we've been doing at NREL is to try to chip away at some of those different cost slices. So here it's obviously a hybrid system, so there's a large fuel component. You can see batteries are a huge component of the cost. Solar CapEx is a big component of the cost. So we'll try to look at each of those cost chunks and see where there might be room to bring those down. In this RMI report that this comes from, they broke it out into 6 categories to try to reduce the cost by 60%. And we don't have a target that we're looking at like that, but we're similarly pursuing different levers that can be pulled to try to reduce costs. Related to one of the costs that they had in their stack there was utilization. I want to mention briefly how important load shape is for a microgrid. It's obviously important for any electrical grid. But with low level usage and communities that are still kind of working on economic development, a lot of the load profiles that developers have seen so far are very heavily residential skewed, which doesn't align very well with solar radiance profiles, obviously. So in a lot of our work, we've looked at a representative commercial profile, which is the blue line on the right, and a representative residential profile, which is the orange line. So that blue commercial line has just small uses of productive uses of power during the day. But using that solar when it's available definitely has a large impact on LCOE. The chart on the left there shows what that impact looks like. For each of these three locations, the blue bar is us modeling a commercial profile, and the orange bar is modeling a residential profile. And you can see on the order of the 20 or 25 cent per kilowatt hour difference, holding the total kilowatt hours constant, but just changing the shape of the load. So that's an important driver overall of LCOE. Okay, I wanted to summarize some of the barriers that I've touched on briefly before talking about some of the work that we've been doing in this space to advance these. So I talked about the cost level being high, and there's still being some challenges in accessing the economies of scale that make the big grid work. I haven't yet talked about evaluating demand in too much detail, but that is, I mentioned briefly, that's a challenge with populations that haven't previously had electricity and have just had things that we can use as a proxy, biomass or kerosene, but it's still hard to assess how much electricity will be used when a microgrid arrives. Capacity utilization I just talked about. I mentioned some of those technical challenges. I'll talk a little bit more about understanding how batteries work in this context. Financing is a challenge because of the risk profile and education there. By education there, I mean that commercial banks in Sub-Saharan Africa just haven't done very many investments in microgrids and are still getting a handle on how best to value companies and individual projects. The enabling environment I mentioned we're working on with national governments that are establishing sort of some of the core foundation on the regulatory and policy side that can drive microgrid markets forward. And then there, across a number of these, there's sort of human capital development challenges and opportunities. So it's a long list of barriers, but I think by the end, hopefully we'll see that, in my opinion, there's a lot of good progress being made on each of these. And some of these track with broader international development challenges, and some track with utility business model challenges. But I think there's cause for optimism on most of these where there's been good progress made. So the things I'd like to discuss in this sort of second half is the quality assurance framework that I mentioned briefly. I'll talk about tariffs, productive uses of energy, some cost reduction opportunities, and what we've been calling bundling, or sort of grouping projects or clustering projects to encourage sort of portfolio level cost reduction opportunities. So the quality assurance framework we developed at NREL a few years ago is intended to provide a structure for transparency in the microgrid sector. And it seeks to take what we've learned from successful utility models elsewhere and map it to the unique context of microgrids for electricity access, with a focus on defining things like service levels, what customer segments might look like, and how power systems should perform, and what metrics should be used to understand if they're providing the electricity services they're supposed to. And I think it has an important role for each kind of key stakeholder group within this space. For developers, it provides a common framework to understand system performance and a common framework to communicate with communities about what they will and won't be able to provide in terms of electricity services. I think for investors, it also provides a more common language to talk about microgrid systems, to do things like address that kind of commercial bank capacity challenge in Sub-Saharan Africa of understanding how these business models work and what unplanned downtime is, and sort of how to think about power system performance. So the hope is that it sort of establishes a common language across these different stakeholder groups in a way that can facilitate increased transparency. So I sort of mentioned this, but the sort of two main components of it are levels of service, and that gets into power quality, power availability, power reliability, and again, takes standards that have been used in utility business models in the past and applies them to a setting where it's a microgrid and the devices are smaller and have lower power requirements. And again, the hope is that it facilitates an accountability framework. So ministries of energy can use aspects of the QEFs that are adapted to their context to track what's being supplied to consumers. Consumers can use it to track what they're receiving from developers. Developers can use this framework to look across their portfolio of projects and measure performance and improve on costs and revenues and the like. So I'm going to talk a little bit about tariffs next. So building on the QAF, the first thing that we turned to is understanding, trying to understand better what the tariff context looks like for microgrids in Sub-Saharan Africa, and sort of how you might balance this equation I have up here on the slide. Right now, the costs and revenues are not working out together, and we're calling this a viability gap here. Because of the higher costs I mentioned and the revenue uncertainty that I mentioned. And there's sort of these main options for addressing this are decreasing costs, increasing revenue, or subsidizing somehow. So we took a look at tariffs to understand kind of where costs are, what tariffs might need to look like to create a sustainable business model, and what might be in that space to close that viability gap. So tariffs, obviously, no matter where they are, need to balance a number of different priorities. And I have sort of three primary stakeholders listed here. Obviously, this isn't all. So you know, the governments have very real considerations about what's politically feasible to charge people. They have equity considerations to worry about, and there are urban grids that are charging certain prices that people use as a benchmark. Developers obviously would want to charge what people are able to pay, otherwise it won't work, but they may be interested in a tariff that's higher than the main grid tariff in an urban area in order to be able to recover costs for what's a costlier system, typically on a per kilowatt hour basis. And the customers, you know, are also interested in similar things in terms of equity. They're interested in having power that they can afford and power that's useful for them to, you know, nobody, as is commonly said, nobody actually wants just electricity. They want the things they can do with it. So that's obviously true here as well. So I put these, if we go back to the kind of grid extension, microgrid, solar home system spectrum, we can sort of look at the cost of those different options as well, and then map that to what options might be for tariffs. So I have on the left there national utility tariffs. There's a big range. It varies a lot by country, but we can call that 5 cents to 30 cents per kilowatt hour. On the right side, there's sort of alternative energy costs, which also have a big range. Could be a solar home system, could be kerosene or other local energy options. In the middle are microgrids again, that are maybe in the 50 cents to $1.50 per kilowatt hour right now. So if we map that spectrum to a set of options on what tariffs might look like, on the left, there's kind of charging a uniform national tariff, which has kind of sort of obvious advantages of everybody being charged the same tariff, but has some challenges of not being able to cross-subsidize the cost the way you can with the big grid to make that workable for sustainable business model without some other form of support. And on the right-hand side, we have maybe a fully flexible tariff where a microgrid operator can just decide what they think folks are willing to pay and what would be the right price to the tariff to charge on the basis of what value they might receive. So that would be limited by customers' ability to pay, and obviously would have potentially political challenges or considerations from the perspective of the government. And in between, there are different shades of things. It could be a regulated cost reflective tariff that either has a cap or it has a standardized methodology. It could be an auction-based system that looks for the lowest possible tariff that developers would be willing to charge to still pursue building microgrids. So there's a sort of spectrum of options, and let's say from our experience so far, this is very much an open conversation, how exactly this will come together in many of the countries that we've been working with. One thing I'd like to mention here before turning to productive use, a little discussion on productive use, is that a big consideration in what tariff to charge and just a general concern in the microgrid space is if you build a microgrid, what happens when the grid arrives? And there's a bunch of pieces to that discussion, but it also relates to this tariff decision-making process. It's obviously a concern for a microgrid developer and investor if the grid is going to arrive and be duplicative with a microgrid in some way. But on the other hand, there are some political challenges with making a concession and guaranteeing that the grid will not come to a particular place to encourage microgrid deployment. So we could talk about that a little bit more. That's a big issue that comes up across a few different aspects of microgrid deployment. Okay, so if we look at trying to improve the revenue side of the equation, one potential avenue to increase capacity utilization and again access some of those things that everybody actually wants with electricity. Productive use of energy is an avenue to pursue. And by productive use here, we just mean demand for electricity from small industry and businesses. And we have some sample load profiles over there on the left, but it could be a bar, it could be a phone charging kind of kiosk, it could be a shop, could be an ice making business, which we've run into in a couple of places. But productive use has kind of benefits of providing more consistent revenue sources, supporting community development, economic development in communities, and shifting the load towards times of the day when solar can more directly contribute without passing through the battery. There's some challenges here, but also some good opportunities or promising avenues to explore with productive use. We recently did, with a partner, Energy for Impact, an assessment of a few different productive use business models, just to do some of the quick math to see how viable they might be and under what settings. And this is an example for an egg incubator business. And obviously, these numbers are kind of placeholder. They would depend context to context, but gives you a sense of what the business might look like and what tariffs, to tie it back to the tariff conversation, what tariffs people might be able to pay to support their productive uses. So shifting gears a little bit, the tariff and the productive use pieces, we're sort of looking at shoring up the revenue side of the balance sheet. We've also been looking at cost reduction opportunities, and a big one we've been looking at recently is batteries. And you saw from that RMI microgrid cost reduction graph that the battery was a big green chunk there in the bottom of the cost stack. The batteries could be anywhere from 20 to 40% of the life cycle cost for a microgrid. So a lot of the work we've been doing with developers is to try to see how that cost could be managed or what would be optimum to do to pursue life cycle cost savings. So we did an analysis that's forthcoming on this topic and looked at how best to condition a battery. There's a lot of uniqueness to running a battery in a microgrid in Sub-Saharan Africa relative to other uses of stationary batteries to date. And in general, stationary batteries in larger microgrids are still an area of experimentation in developed markets as well. So we looked at how do you condition the battery? Is it necessary to have an air conditioner in there to keep the battery comfortable? Or are there construction material choices you can make that could manage part of the thermal changes inside the battery container to manage battery lifetime? And a number of the developers we've been working with have been looking at this decision between lead acid and lithium ion batteries at a high level. And obviously lead acid batteries are sort of tried and true and have been option that many microgrids that are out there to date have been using. But with lithium-ion batteries coming down in price, there's been more microgrid developers that are considering investing in a switch to lithium-ion batteries. So we also looked at that across locations and across HVAC configurations rather. I can talk more about this in Q&A, but I'd like to get through a couple more slides here, so I'm going to end there on batteries. But I'll just say that I think there's a lot of potential for batteries to be managed in a way that reduces the cost there and decreases the number of replacements. And I think it is a good time to be asking the question about whether lithium-ion batteries or lead-acid batteries make sense, and for who and in what settings. Last sort of large topic I wanted to cover on the cost reduction side is work we've been doing on bundling. So the other aspects of cost reduction that I've talked about so far are kind of looking at one individual microgrid and how to decrease costs. For this bundling work, this is again with Energy for Impact, we tried to zoom out a little bit and say, where might there be benefits from bundling projects together into portfolios more frequently or more easily? And we divided that into sort of operational bundling and financial bundling. And the financial bundling, I think will feel similar to other areas where you might try to put together pooled funds, or in general, create portfolios of any type of project really to diversify risk and to create larger kind of minimum investment sizes. An individual microgrid that is maybe 50 kilowatts of solar and a 100 kilowatt hour battery is not a big enough investment to justify transaction costs often. So the idea here is to sort of pool funding on one hand and pool projects on the other hand to increase access to finance at better rates. And on the operational side, I listed some of the aspects of operational bundling that could be valuable. On design and engineering, there's a lot that you could do to sort of streamline processes to design systems, or a cousin of that is streamlining processes to identify sites for microgrids. We talked about productive use. On the remote monitoring side, just as in with developers in the United States, there's potential learning from deploying a lot of systems and effectively monitoring them and having consistent O&M plans that could lend themselves to things like predictive maintenance and the like. So I covered some of the things that we've been working on very quickly. Obviously, we could talk about microgrids for several days. I tried to just give a lay of the landscape of what some of the challenges are and what we've been working on at NREL. But there's a number of other things that a number of other organizations are working on. I've listed just some of them here. Some we're working on, some others are working on. There's ideas of containerized solutions, a mini grid in a box. We're really interested in microgrids that be more modular, that could scale in size over time more easily. There's some interesting technical and business model questions that will go with that. Simplify construction processes. I talked about remote monitoring. There's room for improvement in commissioning. So there's a lot of things that can be done, and we have a good long list of things. So I think coming back to that barriers list, I think I have it here. In that speed round of things that we're working on and that quick bullet list there, I think we probably saw that all these barriers have things that are actively being worked on to address them. So while it's a sort of challenging business environment right now for microgrids, there's a lot of activity and there's a lot of really good ideas on ways to push on different aspects of making these more sustainable business models to get out to some percentage of those 600 million people who still lack access to electricity services. So I'll stop there for time to get to Q&A, and I'll just express again that we at NREL are appreciative that Power Africa has brought us in for this journey, and it's been a lot of fun to work in this space. Neil, I don't know if you'd like to start with questions or. If you can hear me.
Yeah, can you hear me, Eric?
Yeah, there you
Awesome.
are.
I was stuck on mute there. Sorry about that. But awesome. Thanks so much for such like a good and comprehensive presentation. I think it's something that's really, really interesting, and there are definitely a lot of folks, to put it mildly, who don't have electricity, and we have to figure out how to get it to them in the right way. So we do have some questions coming in, and we've got probably about like 10, 12 minutes here for Q&As. So we'll jump right into it. But if you're still with us and you have questions, just use your Q&A box in the Zoom webinar interface and type it in, and we'll get it to Eric. Kind of one of the first things, and I know you've specifically been involved with Power Africa, but one thing we were thinking about was, has NREL done work in other emerging economies that have a significant kind of rural off-grid population that the government or private industry or whoever is looking to electrify? Places like India and South Asia come to mind. And if you have, are there learnings that you're aware of that you're trying to integrate? And if not, are there sort of like learnings that you're taking from other organizations that you're trying to apply to the African setting?
Yeah, that's a great question. The short answer is yes. But for specific examples, we've done a lot of work with remote communities in Alaska that have a lot of valuable insights to lend to this market. So in practical terms, a lot of the engineering skills at NREL that are being brought to this microgrid context started off either in kind of working on Alaskan microgrids or remote power systems, or another category to throw in there is military bases. So at other parts of NREL, we work in other sizes of microgrids and other contexts. So it's been fun and interesting to map some of those lessons learned. And on the India front in particular, we're doing we as a laboratory are doing a lot of work in India, and a lot of the developers we work with in Sub-Saharan Africa, not a lot, but some of them also have businesses in India, and we're always looking for places to connect those two markets. There's definitely differences, but I'd say something that I think is more prevalent in India that folks have been looking to map to the African context is more effectively anchoring microgrids around things like telecom towers, where you have a reliable anchor load for both using power and for providing revenue back to the system. And that's something I think folks have seen some success with in Indian microgrids that would be exciting to be able to port over to the African context more effectively going forward.
Yeah, that's awesome. Thanks for that. One question that came in online, which I think is maybe the other side of this coin, is, how do we kind of share, you have the quality assurance framework specifically for folks in Sub-Saharan Africa. Is that kind of something that you could look at or kind of lift to kind of copy paste or replicate? We had a question come in about expanding energy access in the Caribbean, or, thinking about places like Puerto Rico. Is the QAF something that kind of works there, do you think, or is it maybe not kind of like the lift and shift?
Yeah, I think it is a lift and shift. I don't think I've heard that phrase before. I like that, lift and shift. Yeah, I think it definitely is. And a place that we just have recently done trainings on the QAF is Haiti. And I think the QAF is broadly applicable to any of the contexts that you just mentioned. It's intended to be flexible in that way. So it goes from kind of tiers of service that are on the cell phone charger level all the way up to kind of more grid parity levels of service. So I think it's a framework that you could use across the context. And a lot of the work that we end up doing with the QAF is it doesn't it establishes a framework, but doesn't prescribe exactly which metrics you should use or what tiers are relevant for whom. So a lot of the interesting work on applying the QAF is figuring out what national or regional priorities are and how they translate into what level of power a country would like people to have and when, and how that's measured and reported upon.
Okay, can you hear me?
Yeah.
Okay, good. I continue to mute myself. But no, that makes sense. And it's good to hear that it's sort of something that can be replicated or at like the very least referred to in a bunch of different contexts. Um,
Absolutely.
One sort of, I guess, kind of question we have, you talked a little bit about productive load use and sort of the benefits of like commercial load to kind of the LCOE and the economics in general. Does the QAF include slash kind of have you seen a lot of education and community engagement or training um, in communities that you're looking to serve with microgrids to kind of help them put this electricity to commercial uses to kind of make the whole thing more economically feasible?
Yeah, that's a great question. I think the it would be again for on the QAF in particular, a place where the QAF doesn't have kind of specific productive use thoughts, but is set up to be directly applicable to communities that have productive use integrated. In terms of it would translate into kind of what levels of power quality and the like that you might like to look for out of a developer in places where productive use is hopefully encouraged. And in terms of where it is in communities and what's being done to encourage it, I think this is something that a lot of organizations are looking at, both within the kind of microgrid space for folks who come from the power system side and obviously from the broader international development space. We've done some work on kind of assessing, I think I mentioned on one of my slides, assessing what business models might look like and how tariff structures might respond to productive use economics. But I know other organizations have done direct pilots where they test different mechanisms to encourage productive use. That could look like appliance financing is one route. Training and capacity development is another one. I think there's some challenges there, but some interesting experiments that are going on to try to sort of find ways that productive use can be sustainably encouraged. I think it's for us at NREL, it's a space where, I should say, at least for me personally, I think it would be interesting to look at new partnerships with organizations that are working into the agricultural space that have a better handle on what agricultural businesses look like, and then we can sort of lend the power systems expertise a little bit more. So I think partnerships are valuable there. I think the financing piece would be important. I think it's still an open area of investigation and experimentation. I don't know if there's a kind of one model, nor will there ever be to
Yeah,
encourage it.
yeah. I think it makes sense, right? And then it's also, we want to put power in these maybe more remote areas, but then it's also like, what are folks going to do with it? And yeah, it's great to light up your home and charge your phones, but it would also be wonderful to have maybe more economic activity in some areas too.
Yeah, and I think, as I mentioned briefly, that's what people want long term. I think everybody's agreed that would be that it would be good to serve like sort of broader community development goals, whether it's health or education or other things, the electricity. And I think it's just a question of for each community what makes most sense to pursue.
Yep. We've got one coming from the audience here. Curious to hear a little bit more about the debate you mentioned, about the question, what happens when the grid comes? So does this stem from kind of an argument that microgrids are a transition to the traditional grid? If so, kind of what's behind that? Does it make sense that like the grid is eventually going to reach these places, or maybe sort of just longer term, outside of the next, say, 10 years or something like that? What's the future look like here?
Yeah, that's a great question. Yeah, as I mentioned, it does come up a whole bunch. There's a few aspects to it. So I think other things equal, the microgrid could be the long-term solution from a technical perspective. That it could provide kind of grid parity services. In some places, microgrids already supply higher quality power than some of the main grids. The question is a little bit of kind of in some ways, a timing or planning question. That from the perspective of a national government that's seeking to electrify, to reach 100% electrification, say by 2030 or something. That goal wasn't just put into place today. They've likely had a goal for some time, and in some settings, there's been commitments that a grid will come to people in certain areas. So there's a situation, I think, where the national government, for good reason, would like to guarantee people grid access, or would genuinely like to get it to them as soon as possible. But from the perspective of a microgrid developer, that introduces complexity at the very least in terms of what the payoff period looks like and what happens if the grid does get extended to where a microgrid is. Because the scales we're talking about, microgrid might be a 20-year or 25 or 30-year investment. So even if the grid is not nearby yet, it may be by that time. So I think there's just sort of those competing natural positions of some of the different stakeholders. A way that it's been addressed in part, I think, not addressed, but one mechanism of mitigating this concern is that in some places the distribution network is built by the national utility and owned by the national utility, and the microgrid kind of provides the generation and manages the business of a microgrid, but the utility owns the wires. So if the grid did arrive, the wires are built to the national grid code and are more readily theoretically interconnected with the grid when it arrives. So different countries are looking at ways to find sort of a compromise where governments can respond to commitments they've made, but developers can still feel confident that they aren't potentially facing a stranded asset in 10 years.
Yeah, thanks for that. We got time for one more. I hope it's not too loaded for the minute or so we have left. But you brought about bundling from a financing and an operational perspective, and it seems like it makes a lot of sense, at least in kind of a theoretical and an academic setting. Have you seen it working on the ground? Because the other aspect of it is it feels like it would bring a lot of kind of coordination difficulties. And how do you kind of get smaller parties moving in the same direction, or different developers kind of willing to use the same kind of O&M contracts or whatever it might be that we're trying to share to reduce costs. So just wondering a little bit about that, and then we'll probably wrap up.
Yeah, that sounds good. Yeah, no, that's a good question. I kind of glossed over whether we're bundling within one developer's portfolio or if it's across developers. But within things like O&M, cost improvements or associated reliability or performance improvements would more likely be within the kind of one developer's purview, maybe across regions or within one region. But if you look across developers, if there are kind of performance monitoring and reporting standards at a national level, such that information can be effectively shared between them, that could go a long way towards making financial bundling more straightforward, which is anywhere else where you see sort of pooled projects for investment, there's basically always some sort of standard that underlies that, or a common reporting mechanism. So in some ways, the QAF is a common reporting mechanism. The way certain businesses have accounting standards or other norms that they report that allow investors to more easily put projects together or move between different developers without learning a whole new kind of financial language.
Thanks. That makes a lot of sense. And I think we are now out of time. So thanks everybody for your questions and for staying with us. But we're going to wrap things up. This concludes today's talk: Opportunities and Obstacles to Microgrid Deployment in Sub-Saharan Africa. Eric, thank you so much for joining us today. As you mentioned, we so often cover domestic development and issues there in the webinar. So I think it's great to get an international perspective and hear about the work that you and the lab are doing to expand energy access abroad. View a recording of this webinar, please visit the Events tab on Yale's CBAE website, or access the recording through CBA's YouTube page. It should be up in a couple days. Thanks again for joining us. This is our last webinar of the school year, so I wish all the students a great summer, and we'll look forward to continuing the webinar in the fall. Until then, this is Neil Kincannon from Yale's Center for Business and the Environment. Bye.